Let's see the AP Calculus BC, the question 3. The continuous function f is defined in this closed intervals that is as small or equal than 5 and bigger or equal than 6. So I think this line should be like this. Yeah. Make it a little bit down. Make it a little bit down to here. And it's also have a part of from -6, -6 to the 5, and we don't know what it looks like from the -6 to -2, and also it shows a portion of the graph from the -2 to 5. Consists 2 line segment, I think this one and this one, and a quarter of the circle centered at point 5, 3. Is centered in here is a quarter of the circle, the quarter of the circle in here. And it is known that point 3, 3 minus the square root of 5 is on the graph of f. So it must be have a point in here. This one is 3, 3 minus -5. And it said for the first question, it said from 5 to -6 to 5 of the f dx is 7. So the area from -6 to from the part of we don't know and the part we know, the whole area is 7. Find the value from -6 to -2, the ff dx. So the part we don't know. To find the part we don't know. So the part we don't know, I think this part. Yeah, this part from -6 to -2, we don't know part. Show the work that leads to your answer. So the first thing we need to think about that's the whole area from the whole area point, and change the color to the purple. Yeah. So the area we can just cut the area from the 2 to 5. I think 2 to 5 is this part. So we can use the whole area. We can use the square. I think we can. Let me change the color. We can use the square to minus this, make it look better. I think it should be looks like this. Yeah, make it more perpendicular to each other. Yeah, so the whole square. Use the whole square to minus this quarter of the circle of area. We find this area. So this area we can definitely think this area is an integral from 2 to 5 of the f of x dx. Yeah, this part, this part, and we also have a part from this one to this one, this one to this one. We can see this part. We can see this. Let me show you. I think this part, because this the slope is -1 for this one. Slope is -1, so we have a part. This part is a positive, and this part is negative. So they will eliminate each other. It's the positive area and the negative area. So this part is positive. And let me change the color into a green color for the positive, for a red color for the negative. And the positive and negative card, they will encounter each other. Yeah, they will neutralize each other. So this part will be 0. And in here, let's see another part. Yeah, for this part and this part, we can see the slope is from here's the 1 to 1. So this slope is 2. Right, slope is 2, and this one is a area of this triangle will cut half of this part. So we will see this area is a negative. This area is a positive. Yeah, positive. So these two areas will eliminate each other, and the area, the thing really have an area should be this part, and this part, and this part. So we have a part like this. Part like this. So this part is the place really have an area. So this part we can make the integral from. I can think it's another integral from the -2 to 2 of fx dx. Yeah. So this whole area is fx. So from -2 to 2, the area should be this is a trapezoid. This is a trapezoid. We know the head. And let me use another color. And so we can have the head of this trapezoid is 1. And we have the upper side and the downside. And so upper side plus the downside is 1 plus 3 multiplies 1 divided by 2. We got a 2. So this whole area is actually equal to 2. Yeah, we can see this thing. This circle and this triangle and this triangle, they can fulfill each other and make this kind of is like a rectangle. So 1 multiplied with 2 is also 2. And this part we can use the whole area of the square. The square. Let me use a right color for square. Yeah, square. So the square will equal to the 9 minus the whole square minus the right part, this right part, this part, this semicircle, so this no semicircle, the quadrocircle part. We'll find the purple one. The quadrocircle, we see the radius is 1, 2, 3. So 1, 2, 3. So this pi r squared. So this will be pi multiplied with 9 and divided by 4. Yeah, so it's divided by 4. Yeah, and this part will equal to 9 minus 4. 9 over 4 multiplied with pi. So this is a whole area. This area and this from negative to 2, this area, and we know the whole area from the negative 6 to 5 is 7. So we can use then we want to find negative to negative 2. So this will be part of this negative 2 and negative 6 to negative 2 will be this part. So we will add this 3 part together to get this 7. So I will write like this one. For the negative 6 to 5 of fx of dx will equal to the part we want to know. Yeah. So I will copy this part. Yeah. Okay. So this part. The part we want to know, and another part is this part. Another part is this part. Yeah, the blue part, and then we plus this one, plus the blue part, and then we also plus this purple part for the 2 to 5. So this is the part the whole part. So this part is equal to this 2 part, the 2 part plus this part, and so they will add together. So from negative 6 to 5, from this part, and this part add together. Then we write it down. We substitute the number. So this part will equal to 7. And plus the part we want to know, negative 2 fx of dx, and plus the blue part is 2, and plus the right part is 9 minus 4. That's 9 divided by 4 pi, and so we will get our this part equal to the 7 minus 9 minus this whole thing. Yeah, so the whole thing is equal to 7 minus 2 minus 9 and plus 4 over 9 over 4 pi, and this whole thing will equal to, and let me write this thing down, copy, and this calculate it out. So this 7 minus 2 is 5. 5 minus 9 is negative 4. Yeah. So negative 4 plus 9 over 4 pi. This is the answer. Okay, that's first question. Here is question B. Evaluate this integral. So we can start from here because this is a 2 multiplied with a derivative of the fx. So we know this antiderivative of fx. So we can write this down like is equal to the 2 multiply of antiderivative f prime of x is f of x plus a 4x. And we want to find this from 3 to 5. And we write if 2 of f, 2 multiplied with f5 plus 4 multiplied with 5 is 20, and minus the 2 multiplied with f of 3 plus the 3 multiplied with 4 is 12. So we got 2 of f of 5. 2 of f of 5, let's check. 2 of f of 5, this is fx, and f of 5 is 0. So 2 multiplied with 0, we got a 0. Plus 20 minus the 2 multiplied with f3. 2 multiplied with f3. And we already know f3 is 3 comma 3 minus square root of 5. So this will equal to and minus 2 multiplied with square of 5. 2 multiplied with 3 minus square root of 5. And plus a 12 inside. Inside of the plus a 12. So we just do some calculation. Then we do calculation step by step. So this one will equal to 20 minus 6 minus 2 multiplied with square root of 5 plus 12. And the 12 minus 18, we got a 2 plus 2 multiplied with square root of 5. That's the answer for the question B. Okay, let's go to question C. We have the function, the gx from -2 to x ft of dt. Find the absolute maximum value of g on the interval from -2 to x, x from -2 to 5. So justify your answer. So if we see the picture, we know the from -2 to x, this thing will be from -2 to somewhere in the future of this area, this accumulative area from -2 to the other side. But this is from -2 to 5. So we can see this thing. I have already drawn this thing out. So we can see this thing. This positive slope. We have this thing to the slope of 0. Then it goes to here. I need to a little bit modify the thing. I think I should not just because I see the slope goes down. As slope goes down, so this one will continue basic like this in here, because this place is still a negative a 0 of f of x of 0. So it's equal to the derivative of this red line. I highlight this red line. So it's basically like a derivative of this one, and the purple highlighted the red line is an antiderivative of this line. And we can see this one is basically is a maximum. This is a relative maximum. And this is a relative minimum, this is a relative maximum. So we need to justify. And we also can observe this term. This kind of thing is a positive and negative. They would eliminate each other, and the positive and negative eliminate each other. So from the rest of the part, this blue part and this purple part, yeah, they will accumulate the area to 5. This is the biggest. So we needed to justify. Also, we need to justify our thinking. Let's do this. So first we have we can use one fx equal to 0. We have x equal to let me check, x equal to -1, or we have x equal to 1/2, or we have x equal to 5. Yeah, so there's 3 point in here. Yeah, 3 point. Let me highlight this point, and this point. So we just substitute in. We see the g of then we see the accumulation to g of -1. G of -1 is -2 to -1 ft of dt. This part will equal to from -2 to -1. So we have the 1 multiplied with 1 divided by 2, so it's 1/2. The accumulation of the area is 1/2. And we have g of 1/2. G of 1/2 is equal to -2 to 0.5 ft of dt. And because we can see this relative minimum here, and we see this accumulation of area from here to here, they eliminate each other, and this one is 1/2 multiplied with 1 divided by 2, this 1/4, and also this -1/4. Yeah, -1/4. And also we can see from the g of 5 is of -2 to 5 ft of dt is the whole area. Because we have already find this part of area in the previous question. In here is from -2 to +5. So this two part plus together. The two part plus together 2 plus 9 minus pi 9 over 4. This will equal to 11 minus 9 over 4 pi. This is the answer, and justify our answer, we can see this one is the biggest, and this one is from the value, find the absolute value g in the interval. Yeah, this interval should be g5. G5 is the maximum. This is the answer. For the last question of the question 3, the question 3D, we can just write equal, because it's find the limitation of this thing. We just directly substitution of the 10 of power of 1 and the -3 f of prime of 1. So the derivative of f of 1 is f of 1 minus arctangent 1. So this thing, if the numerator and denominator aren't zero, we will find the answer. Because here is a 10 minus 3 f prime of 1. So derivative in 1. So derivative in 1, I have already highlighted this place. Yeah, we have this place. Yeah, this place. Yeah. So this place we can see this 1 2 over 1. So this the slope is 2. The slope is 2. So we substituting this will equal to 6. Equal to 6. And f of 1. Let's check f of 1. And the f of 1 is in here is equal to 1. So this part is 1 minus arctangent 1 is 45 degree, and it's pi over 4. So the answer will equal to 4 over 1 minus pi over 4. Yeah, that's the answer. 4 over 1 minus pi over 4. Okay, this is the whole response to the question 3. I wish you enjoyed this video, and see you in the question 4.